These drivers lost control at very high speeds. The result was tragic for one driver and fortunate for the others. But why? What made the difference between walking away and being carried away? The answer can be found in some of the most basic laws of the physical universe. Hi, my name is Griff Jones. I teach high school physics. And behind me is the Insurance Institute for Highway Safety's Vehicle Research Center. It's a fascinating place where research engineers assess the crash performance of vehicles by running tests, and where they evaluate new technologies to prevent injuries, like this state-of-the-art head protection system. What's exciting for me is that this is a laboratory of practical applications in the subject I teach. And because they're set up here to crash cars and analyze those crashes, this research center provides a perfect venue for illustrating the physical laws that govern the outcome of car crashes. So follow me, and for the next few minutes, I'll take you behind the scenes where we can explore the basic science behind vehicle crashes. Let's learn about car crashes and physics. Why'd this dummy get left behind? It's called inertia, the property of matter that causes it to resist any change in its state of motion. Galileo introduced the concept in the late 1500s, and almost 100 years later, Newton used this idea to formulate his first law of motion, the law of inertia. It's why the dummy fell off the back of the truck. It was at rest, and it wanted to remain at rest. That's inertia. It's the same property that keeps the china on the table as you pull the tablecloth out from under it. Now, what about a body in motion? Am I a body in motion? You bet I am. I'm moving 35 miles per hour. But from one perspective, it may not look like I'm moving at all, because in relationship to the passenger compartment, my position isn't changing. But if you look at me from the outside, you can see that I'm moving at the same speed as the vehicle, in this case, about 35 miles per hour. And if Newton was right, and we know he was, I'm going to keep on moving at the same speed until an external force acts on me. Now, what does this mean to occupants of a moving vehicle? Watch this. See how the car and the crash test dummy are traveling at the same speed? Now watch what happens when the car crashes into the barrier. The front end of the car is crushing and absorbing energy, which slows down the rest of the car. But the dummy inside keeps on moving at its original speed until it strikes the steering wheel and windshield. This is because the dummy is a body in motion traveling at 35 miles per hour and remains traveling 35 miles per hour in the same direction until acted upon by an outside force. In this case, it's the impact with the steering wheel and windshield that applies the force that overcomes the dummy's inertia. Inertia is one reason that seatbelts are so important. Inertia is one reason that you want to be tied to the vehicle during a crash. If you're wearing your seatbelt, you slow down with the occupant compartment as the vehicle's front end does its job of crumpling and absorbing crash forces. Later, we'll talk about how some vehicles' front ends, or crumple zones, do a better job of absorbing crash forces than others.